So you did this warm-up as we were finishing our tests. If you did not finish your test, you need to finish that first. Today's the last day for the test. So while we do this, you do that. Okay? Any other tests out? Make sure you finish that first. Okay, here we go. So if you've been working on this warm-up, all we're going to do is a check for the answers real quick. So I want you to check your answers real quick. Boom. So did you get 7 for 1, -4 for 2, +4 for 3, 10 for 4, and 2 for 5? If you did, great. If you didn't, we're going to actually go over these when we go over these notes because it's the same problems, but we're going to be doing them as algebraic proofs. So I do want everyone to look at the notes for algebraic proofs now. Okay? So today we are going to do these notes. Tomorrow we're going to do the assignment. Okay? And you need to know what algebraic proofs are. So it says, a proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So an algebraic proof is, it says you use proofs all the time in Algebra 1 without even realizing it. I'm telling you, if you could solve the warm-up today, all of them, then this is not going to be hard. The only thing you're going to be doing is giving me a reason for every step you take. Okay? That's a proof, algebraic proof. So what are the steps that you can take? You have to use properties, and that's what we're going to fill in this table right here. So let's fill these in. That first property, it says A plus B equals B plus A. Switching the order is called commutative property. Commute like you're commuting, like you're traveling. Switching, traveling, well, you know, commutative property. It works for addition and multiplication only. The second one, you have parentheses that are associating differently. The A and B are parentheses on the first one. The B and C are in parentheses on the second one. That's called associative property. I'm going to be doing a lot of abbreviation. Does everyone know prop means property? Hopefully. Okay. The next one, if you have a number outside of a parentheses and you multiply into the parentheses, what's that called? Okay, distribution. So that's a distributive property. Backwards from the distributive property, if you take like terms, ax and bx have the same x, right? So if you combine those together, that's going to be called combining like terms. Okay? That's the only one that doesn't have the word property in it somewhere. Combining like terms. We'll be doing some abbreviations eventually, but CLT is how you can abbreviate that in the future. All right, next one. Now this is kind of weird. Any number is equal to itself. That seems very obvious, like 2 equals 2, 3 equals 3, right? There's a property for that. It's called the reflexive property. We actually do use it sometimes in proofs. The next one, if A equals B and B equals C, that means A equals C. You can kind of do a, like hop over the middle guy. A equals B, B equals C, from the first to the last, A equals C. That's called the transitive property. Okay? So, if A equals B and B can be substituted, that's the key word. That's called substitution. Okay? Substitution property. Okay, this next one. A equals B means B equals A. That means you can switch the order. Okay? So just switching the order reminds me of like a picture where it's equal on both sides. And you can kind of, you know, fold it right down the middle and it's equal on both sides. You could flip it over. What's that called? When it's symmetric. So when you switch an equation and flip it all the way over, that's called the symmetric property. And then these last four are all operations. So these last four are going to be called property of equality. So check it out. If you add c to both sides, if you're adding a number to both sides of an equation, that's addition. Oops. Hold up. My bad. Addition, property of equality. Okay? So, as much as I love writing the phrase property of equality every single time, we're going to end up abbreviating property of equality with POE. Property of equality. Okay? PO. Any of y'all ever play Legend of Zelda? You know about the POs? You got to play Ocarina of Time. Tournament field. You know, with the Majora's Mask, tournament field, you get the POs floating around. Alright, anyways, so if A equals B, and you subtract on both sides C, that's subtraction, POE. PO. You down with POE? You know me. Alright, next one. What if you multiply both sides? That's multiplication, POE. And if you divide on both sides, that's division, POE. True? Alright, so I'm going to leave that frozen on the sideboard here as we move through this. And just so you know, in the future, I'm going to give you little half sheets like this in my hand. It's going to have all the properties on it, so you don't have to have these properties memorized, but you got to know which one to use which. So that's why we're going to do these notes. So go ahead and flip it over to number 1. So on number 1, it says, now we can begin writing algebraic proofs. Each proof begins with given and prove statements which restate the hypothesis and conclusion of the conjecture. In a 2-column proof, you list the steps of the proof in the left column and write the reason for each step on the right column. So everybody, this is called a 2-column proof because there are 2 columns. On the left is going to be statements. Now, some of them will be easy like this, where they give you all the math. Look at that. All the math is already there. But you need to give me every single reason. Y'all ever heard that song by Earth, Wind, and Fire? Reasons. Reasons that we prove. Reasons. Not raisins. Not sun-dried grapes. Reasons. Okay, here we go. First step. Y'all ready for a gimme? An easy one? Is every single time. This is going to be super easy. Step 1 is always going to be given. Okay? Check it out. Right there. Given. You always write it right there. Every time. Okay? So literally every single time, step 1 is given. Now, on the left-hand side, step 1 is always what is given, and the last step is always what it is asking you to prove. Okay? So I'm telling you the structure of these proofs. It's always starting with given, the reason is given, the last step is prove. Everything else needs to be filled in. Okay? Now, like I said, every one of these problems was on the warm-up, so you hopefully already recognize all the math here. On the left-hand side of this equation, these parentheses disappeared. What happened from step 1 to step 2? Okay? When you see parentheses that kind of just go away, that probably means they distributed the number in front of the parentheses. And that's what happened, right? 2 times x, 2 times negative 3. So we're going to write distributive property. You do need to put prop. You can abbreviate, but you can't eliminate the prop. Why? Because I need to know what you're talking about. Distributive what? Distributive what? All right, so next step. What did we get rid of from step 2 to 3? The minus 6. How do you get rid of a minus 6? Adding 6 to both sides. So that was what property? Addition. Property of equality. Now, look at all that writing you'd have to do right there. So, henceforth, we can go ahead and put POE. Okay? And everyone knows POE stands for property of equality. If not, you would see it on your little half sheet. Property of equality. Okay? Now, last step. How do I get rid of the 2 in front of the x right here? Divide by 2, because it's a coefficient. So when I divide on both sides, I'm going to write division POE. So hopefully you already solved this problem on your warm-up. All you're doing now is making another column with every reason, and that's it. So is this hard or easy? Let's try number 2. Good. Now 2 has a lot of steps, but that's all right. We just do it step by step. Number 1, what's always the reason? Given. Let's write that down. What happened between step 1 and step 2? The parentheses disappeared because we distributed the 8 into the x, into the 2. So distributive property. Now everybody, step 3 can be confusing for some people. Does everyone see how we added 16 plus 3 to get 19? So, some people would like to think that that means addition, property of equality. But I'm here to tell you, if you only add some numbers on one side of the equation, that's not a POE, because it's not E, equal. Okay? Here's the deal. If you take terms and combine them by adding or subtracting only on one side of the equation, that's called combining like terms. Okay? So, this is one of those CLT, combining like terms. You can abbreviate the combining for a comb. Combining like terms. Now, next step. There's x on both sides. What do I do when x is on both sides? Do I combine them or get rid of one? Get rid of the smaller x, which is 5x minus 5x on both sides. What property was that? Subtraction, POE. From step 4 to step 5, what went away on the right-hand side? Not the 7, on the right-hand side. The 19 is gone because what happened? Subtraction, right? Right here. The 19 went away by subtracting 19. 7 minus 19 is negative 12. So that's called subtraction POE. Can you do it 2 times in a row? Yes. Okay. Does everyone see step 4 and 5 are both subtraction? That's fine. I don't want you to freak out if you do the same thing twice, because one was adding the x's, or one was subtracting the x's, one was subtracting numbers. Now, how do I get rid of this 3 in front of x right here? Divide by 3. So that's division, property of equality. Now, class, step 6 to step 7. The only change was a switcheroo from the left and the right. Okay? So let's look at our properties and think about this. Which one switches? That's called symmetric property. Remember, symmetric means same on both sides, so you could flip it and be the same, right? So that's why we're going to write symmetric property. You only use that if x was on the right and you had to put it on the left, okay, when you switch the equation. So, any questions with number 2? Y'all ready for 3? If you're ready, go ahead and turn to number 3 and be amazed. What do you notice about number 3? Oh my goodness. The training wheels are off. Now we have to solve it ourselves on the left-hand side and give the reasons on the right-hand side. But we can do it. That does mean that he has to give up all his Bakugan. All right. On number 3, what do I always write first? Given on the right side, but on the left side, make sure you write what is given, right? So 5x plus 10 equals 3, parentheses 3x minus 2, given. This is easy and fun. I'm glad you said that. So on number 3, what do we do first? Distribute. Those parentheses let you know they got to go first. We distribute. So 3 times 3x is what? 9x. And 3 times negative 2 is negative 6. And I put what property again? Distributive property. Woo. Next step. X is on both sides. What do? Subtract 5x on both sides. So that gets us 10 equals 4x minus 6. What property? Subtraction property of equality. Now we're going to get rid of the loner on the right side. How do I get rid of that? Minus 6. Yeah, we're going to add 6 to both sides. Addition property of equality. POE. What shalt I do next? I shalt divide by 4, which is the division property of equality. Am I donezo? Okay, does everyone see x is on the right-hand side? X needs to be on the left. Whenever you flip it around, that's symmetric property. So x equals 4, symmetric property. That's it. Because you're trying to prove this. So here's why that matters. It says prove x equals 4, not prove 4 equals x. Even though they're equivalent. And I've always told you they're equivalent. But the reason why they're equivalent is because symmetric property of equality, or property of equality. There's a reason why it's the same. Instead of assuming it now, you are proving it with properties. And that is some knowledge. So, number 4, what shalt I do first? Given, write that down. Write that given, like it's Thanksgiving. What do I do first? Okay, distribute. Seven times x is 7x. 7 times 4 is 28. Next step. Everyone's with me? Get rid of one of your x's, your smaller x. Let's subtract 7x on both sides. That gives me 28 equals 3x minus 2 because of the subtraction property of equality. On the right-hand side, what's my loner? The minus 2. How do I get rid of minus 2? Plus 2 on both sides. So that's addition property of equality. Make sure you write this down. So, what do we do next? Divide by 3. Division property of equality. And then symmetry property. Can't you see? So x equals 10. True? The answer was true. All right, next one. Any questions on that one? Anyone still need to get it down? That's fine. Yeah. All right, next one. Number 5. What do I always start with? Given. Yay. One more. So even though it's y, that's all I just asked. All right, so first step, distribute. All right, now what should we do on the left-hand side of that equation? Y'all see, you see that there's two y's there, 4y and 2y? Should we get rid of one or combine them? Combine like terms because they're on the same side, right? So 4y and 2y together, that's going to make 6y minus 2 equals 3y plus 4. We are not using addition there. We are using combining like terms. Okay? And just like before, y is on both sides. Get rid of the smaller y. Subtraction property of equality. And then we get rid of the minus 2 by adding 2 to both sides. That's addition property of equality. And then we get rid of the 3 by division property of equality. Now, notice y is already on the left side. You don't need to use symmetric because you don't need to move it over. That's it. Okay? So all this is algebra plus steps in 2 columns, right? So tomorrow when you get an assignment on this, today I'll spare you, right? We did a lot of work, a lot of writing. Tomorrow when you get the assignment, you can do this, show your work, put a reason. You will have a half sheet with all the reasons on it. There's only 4 pos. There's lots of properties, but there's only 4 pos. There's only 4 properties of equality for each operation. Add, subtract, multiply, divide. All right.